Welcome to our integration project, first half of computer engineering at the Autonomous University of Tlaxcala, Faculty of Basic Science, Engineering and Technology. In this integration project, we have done a video tutorial on solving a mathematical and physical problem by using an algorithm which solves.
The main objective of this project is to link what is learning in each and every one of the subjects in order. To solve the problem we will show below. We had a massive circuit with parallel and series circuits, which will solve through Kirchhoff by the method of mesh for the currents in each part of the circuit. For starters, let's take our circuit is divided into 3 sections and each selection will displace a mesh.
Each screen has an intensity which we draw from the equation of the voltage of each mesh according to previously obtained the organization of the mesh. You have obtained and organized the equation as shown below. Proceed to use the algorithm we design.
To begin, we will identify in each equation the following parts. We will identify the numbers accompanying the intensities, and we will start with the number 1 mesh.
We start the process.
We ask for the values of the first equation to be solved as x1, y1, c1, and the value after the equal sign.
The values of the second equation in the same order. In this case, x2, y2, z2, and the value after the equal sign.
Finally, we ask for the value of the third equation x3, y3, z3, and the value after the equal sign.
We need to get the determinant of each one. We begin with the general determinant. We have
According to the
values.
rules, we must write out the first 2 columns of the matrix to the right of the third column, so that we have 5 columns in a row. Then add the products of the diagonals going from top to bottom, and subtract the products of the diagonals going from bottom to top. Here the algorithm does the same thing.
Multiply x1 times y2 times c3 plus y1 times c2 times x3 plus c1 times x2 times y3. After all this, we subtract x3 times y2 times c1 plus y3 times c2 times x1 plus c3 times x2 times y1. Thus we get the general determinant.
Then we must replace the first column with the first column that is after the equal sign. Then
the program does the same preceded diagonal multiplication and obtain the determination of x. We continue the replacing the next column.
Again, we multiply in diagonal and obtain the determinant of y.
And finally, here the program gets the last determinant of c. Once the determinant of c has obtained, program continues to obtain the final values of the intensities. To divides each of the determinants by the general determinant as shown below.
So, were the values of the intensities of our circuit. That's all.